So I'm going to take you through like the major components of the product, and so you have a general feel of how the product is set up. Okay, so there's the core storage platform, which is Swarm. Okay, that's product you've known since we were birthed as a company, and it's it's a symmetric computing environment, no access nodes. You have a huge variety of protection schemes. You can use erasure coding, you can use replication, you can use any of those combinations all the way down to the object level, okay? And it's also smart enough to feed to other clusters through something called feeds for mirroring, replication, DR, whatever, okay? You want to do for distribution of your data, okay? So this would be, and when it copies something from here that's got a particular name, that name is preserved as a flat address space so that you could literally take two of these and plug them together and they would just work, okay? And this could be looked at as a storage supercomputer, or it could be looked at as a massively scalable web server, okay? So this is the core storage engine, and it uses a standard RESTful interface, okay? And it's HTTP 1.1, okay? It looks like, S3 a bit, but it's a bit more powerful and a bit like Swift. So this is the core storage platform, runs on any 86-based hardware, okay, of your choice, and it doesn't matter whether it's homogeneous, heterogeneous. It does self-load balancing. You plug and play hardware as you need it. If you want to add a new node, you just plug it into the network, turn it on. It'll boot up as a part of the platform and participate. If you want to get rid of it, you go up and push a button on the console that says retire. It'll put all the data back into the cluster and it'll shut down. And one of the key components of the Swarm architecture is this idea that you have a bunch of nodes, all of which do exactly the same thing, all of which can service any request, and all of which work in parallel in such a way that they work like a swarm. That's why we call it a swarm, okay? And then the ability for this to operate in a coordinated fashion with no access node is done through heuristics and smart algorithms that are adaptive, that help you load, balance, and manage the cluster based on activity on it. And so it constantly adapts to the load on the cluster, including recovery loads in case some disaster happens. It all adjusts to that as automatically, so you don't have to manage hotspots or manage the activity going on inside a cluster. And that's why it's called a swarm, because if you look at a nature film and you watch a swarm of fish, that's kind of what it looks like. It swarms around when it needs to, okay? So that's the core storage platform. And this scales based on your need and demand and the kind of hardware you want to use. So the next piece that we've added to it is this search capability. And the world of search is, again, part of the web world, and that's why it fits perfectly with us. The search engine indexes all the metadata. So this is where you can take the metadata that's in the object and then put it into a platform that you can scale independently, depending on what your needs are, to provide a search infrastructure against your objects. Now you can search through the standard RESTful API, or you can actually come into the search engine and look at it. So now we've got the common web technology that's evolving. We're using Elasticsearch here right now. And we expect to be committed to this platform as our search technology, and it's considered to be a first-class part of Swarm, but we didn't put it on the nodes because this allows us to separately scale this infrastructure, okay? And this becomes very important because in object storage versus a file system, the metadata of the objects represents the namespace, not the actual name of a file. The name of a file, yes, you can give something a name here, /a/b/foo, but it still is just metadata. The name is just metadata, okay? So all the metadata goes in here. And then, you can natively access this using HTTP, but you may want to do some other things. And so we have a service out here called CloudScaler. And of course, clouds are nebulous, so we might want to make it a little nebulous, but it's a cloud scaler. And so what CloudScaler provides is a place to hook into some standard corporate directory stuff like LDAP and Active Directory and it allows you to manage tenants, okay, and users in those tenants, and delegate this out. So I can have a cluster with 100 tenants, and I can make John Toigo one of the tenants, and he can manage all his domains that he could hand one to Mark, and one to me, and one to Adrian. We could each manage our own. So it provides you a multi-tenant environment. It also provides you personality layers. So if you want to talk another language, we'll let you talk another language to us. And I'll tell you from a strategic point of view over time, you talked about all those disparate clouds, right? One of the things we have is a design in the background that we actually called the Hypercube, where you could read and write through any of these, and that way you could read, you could literally have an S3 guy out here that it was reading from, and it's moving the data into here and deleting it from here, so that you go through basically what I would call a on-demand loading of the data that you're using. And so the old S3 data might not move, but the stuff you actively use gets in here. But the idea is that you get some protocol layers you can talk to. You can talk to the standard corporate environment. You can manage it as a multi-tenant cloud, both enterprise and as outside world. So you can bring untrusted users in through this, and say British Telecom and who else? Telefonica. They use it as an S3 cloud interface as well as a cloud interface to our stuff. So this provides you really an authentication server, and multi-tenant includes audit feeds. This includes usage feeds. This includes places where you would apply quota and all the stuff that you would do around it in billing. It's got an engine for doing all that stuff. So some of the normal infrastructure you would need for a big cloud. Okay, and this itself has a management interface that is RESTful as well. So you don't it has a portal, so you can talk to it and do all this through a portal. But you don't actually have to use the portal. You can use the management interface to talk directly to it. And again, in fact, that's how Telefonica and BT do it, is they actually talk to the management interface, and it provides this mechanism. And this, just like everything we have here, this you can repeat, and it's RESTful, and it has no affinity. So you don't have this problem. You just take a load balancer and put it out front, and it spreads it across it. But you lose a connection here, you can go to another one, and that connection still works. There's nothing there to stop it. So it's lightweight, reverse proxy, that gives you all the stuff you need. And it's the same thing for the search engine. If you lose your metadata set on this search engine, then you can simply rebuild it. You would prefer not to, because it might take some time depending on the size of your cluster. But this again is basically stateless in the sense that there are these things inside Swarm called feeds that know how to start at some place in a data set and methodically go through that data set and do something with it. In the cases of replication, it methodically moves stuff to the other side. In the case of search engines, it methodically re-indexes the stuff. And in fact, these feeds are operating all the time on an active cluster, so that anything written, changed, or deleted goes through this process, and the appropriate things happen in the engine. So there's this internal engine that's always looking at the data. So feeds are a great way to process data as it's coming in and do standard things like extract metadata, okay? And then even put that extracted metadata here. So this is the actual core engine. There is a clustered services node that is actually just a console that allows you to manage the cluster from one place, that gives you a view, lets you boot up the stuff, has its time servers, does all the basic services that you would need, but it's really just a management unit. You can run it in a VM, and in fact, you can run all of this in a VM except for Swarm.